All right, let's talk about how to solve rational equations. So a rational equation is just an equation where you have fractions in it, and it might be one term, it might be like all the terms. Like, let's see, on the next page, like see how these are all fractions. So those are called rational equations, and it's actually very straightforward. You guys already have all the skills to be able to do this, but we just have to tie them together for you, okay? And you've already done this with, 4/3 plus 3/7 or something like that is equal to x, not plus, is equal to x. Basically, the idea is you get a common denominator, and then it works out pretty quickly from there. So, all right, I'm not going to read all these steps to you here, but let's go ahead and solve the first one here. So step 1 is to get a common denominator. That means that for this one, we want everybody to have the same denominator. This already has an x here, so we're going to give this guy an x, which means we need to multiply by x on the top as well. And then the same thing on the right here. If we divide by x, we're going to need to multiply by x. And the reason we're doing that is because if you divide by x, it changes the number. But if you divide by x and multiply by x, you're actually multiplying by 1 because x over x is 1. So it doesn't actually change the number, right? 4x over x is the same as 4 because we say the x's cancel. That's the word we use for that, right? Okay. So now what we have here, if you rewrite this, is we have x squared, right? X times x squared over x plus 3 over x is equal to 4x and over x. And what we do here is, and the order that you do this in doesn't really matter, but on the notes here I said add, subtract the numerators. I'm going to actually get rid of the denominator here. So what we're going to do here now, this is going to seem weird, is we're going to multiply everybody by x, which is the denominator there. And I want you to watch what happens on both sides, right? So we multiply both sides by x. These x's just cancel, and we're left with, on the top, just the numerator. So x squared plus 3. And on the right, those x's cancel, and we're left with just 4x. So here's the trick on these. Get a common denominator, and then whatever is in the numerator, that's your equation, right? See how the yellow part is just what we're doing here? So that's basically it here. And then from here, we're just solving, right? So you guys know how to do quadratics, hopefully. So if I was solving this, I would subtract 4x from both sides, get everybody on the same side, and then I'd probably factor. X squared minus 4x plus 3 equal to 0. I think this factors. Let's see. We want two numbers that multiply to make 3, add to make -4. So I think -3 and -1 would work here. Yep, that would work. Okay. Now, you have to be really careful on these, and I want you to look at step 6 here. Okay, so it says check your solutions. If you have a solution which does not work in the original equation up here, because of a domain issue, it's called an extraneous solution. And so what I want to do here is I just want to check, right? So we're going to say, hey, x minus 3 is equal to 0. That means x is equal to 3. X minus 1 is equal to 0, which means x is equal to 1. We just want to double check and make sure if we plug in 3 for x, does it work, right? So if we do this, if we do 3 plus 3 over 3, the question is that actually equal to 4, right? And the answer is yes, so that works. When you plug in 3, it works. How about when you plug in 1? 1 plus 3 over 1. Wherever we see an x, we're going to put a 1. Is 1 plus 3 over 1 actually equal to 4? It is. Okay, so both those solutions work. So we would say that the solutions here are x equals 3 and x equals 1. Okay, neither of them is extraneous. If one of them we plugged it back in and it didn't work, it would be extraneous. And we're going to run into a couple of those here in a little bit. All right, that's it. That's how you do these. So let's do a couple more. They get increasingly difficult, but once you understand the main idea, you're good. So common denominator, I'm going to make the common denominator x, so I need to multiply. Just make sure when you give it an x on the bottom that you give it an x on the top as well. So we have x squared over x plus 2x over x is equal to 15 over x. And then we can multiply by the denominator, right? And you really don't have to write this step here in blue if you don't want to. Like if you just want to come down here on this next step and say x squared plus 2x is equal to 15, that's fine. I'm not going to ding you for that. All right, subtract 15 from both sides. And now we've got x squared plus 2x minus 15 is equal to 0. All right, and now we're going to factor this. Hopefully at Delta Math, most of the ones you do today are factorable. I think they are. I don't think we're trying to throw any quadratic formulas at you today. Need two numbers that multiply to make -15 to add to make 2. So I'm thinking 5 and 3 and I need it to be positive. So I'm going to do plus 5 minus 3. So in this scenario, we're saying x is equal to negative 5 or x is equal to 3 when we solve. Now we just need to double check those numbers, make sure they work. So the original equation was x plus 2 is equal to 15 divided by x. So let's try negative 5. So negative 5 plus 2. The question is that equal to 15 over negative 5? So negative 5 plus 2 is negative 3. 15 over negative 5 is negative 3. Yep, so that works. How about 3 for x? So 3 plus 2 is equal to 15 over x, where x is 3. So the question is here is 5 equal to 5? It is. So those both work. So we're good to go there. Okay, next one, number 3. So these are where they start to get a little intense, right? You're like, oh my gosh, how do I get a common denominator for these? And the answer is, what we're going to do here is we're going to actually look at this guy here. This is a little overwhelming because we're like, oh my gosh, is the denominator seriously going to be this times this times this? Like, is that what I'm going to do? The answer is no. It's actually a little simpler than that. What I want you to do is I want you to factor that yellow guy, okay? So I'm going to leave the left side alone here. But I'm going to factor the yellow guy there. The yellow guy, very conveniently, look at these guys, x minus 1, x minus 3. The yellow guy is actually x minus 1 times x minus 3. Okay? So, now, as far as getting a common denominator, what should we make the common denominator? Well, these guys both have x minus 1. These guys both have an x minus 3. So my vote here is that we make any common denominator the green x minus 1 times the blue x minus 3. Okay, so let's do that. On the first fraction, if we give it, what do we need? What does the first fraction need right now? It has the x minus 1. It needs the x minus 3. So what we're going to do here is we're going to come in and we're going to tack on the x minus 3. Make sure you do this in parentheses, okay? So we are going to tack on the blue x minus 3 there. Okay? So that's the first fraction. The second fraction already has the x minus 3. What does the second fraction need? The second fraction needs the x minus 1 there. Okay, so we're going to multiply by x minus 1 on the bottom and on the top. And then on the right, we're good. We already have x minus 1 times x minus 3 on the right. So the right side's good. Okay, now everybody has a common denominator, and we're good to go. Right? So what are we going to do? We're going to multiply everybody by the common denominator. Again, you don't really need to write this out if you don't want to. You can just make the denominator disappear, but on this side, we're going to multiply by x minus 1 and x minus 3, and that's just going to knock out the x minus 1 and the x minus 3 there on the bottoms. Okay, so what we have then is we literally just have the yellow top part here. Like, that's it. That's all we've got. So we have 2x times x minus 3 plus 1 times x minus 1 is equal to 2. Let's distribute here. Not erase, distribute. So that's going to be 2x squared minus 6x plus x minus 1 is equal to 2. So we got 2x squared minus 5x, and then let's subtract 2 from both sides here. So minus 3 is equal to 0. And then this should factor. I only know because I made the problem. I made sure it factored nicely. Okay, so we're looking for two numbers that when we multiply them, we get negative 3. They aren't necessarily going to add to negative 5 here because there's a 2 out in front. So I think we're going to want, it's got to be 3 and 1, but the question is where do we put them? I just know because I've done this problem a few times. I'm going to multiply the 2 with the 3. That'll give me 6. And then I'm going to multiply the 1 with the x. That'll give me 1. That'll get us to negative 5 there. Okay. Let's see. Minus here, plus here. So our two answers here are 2x plus 1 equals 0. So 2x is equal to negative 1. X is equal to negative 1/2. That's one of our answers. Our other answer, solution, is going to be x is equal to 3. Right? Because we set x minus 3 is equal to 0. And I believe one of these is actually extraneous. So if we plug in negative 1/2, if you just trust me here, if you plug in negative 1/2, it does work here. It actually works. Like if you plug in negative 1/2 here, 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 and here, it does work. However, if you plug in 3, it does not work. And why is that? It has to do with this guy right here. So we can do 3 here on the first fraction. 2 times 3 over 3 minus 1, that's fine. But the problem here is when you try to do a 3 for the second fraction there, right here, what happens here? See how you have 0 on the bottom? So basically you have 6 over 2 plus 1 over 0, and you can't divide by 0. We call that a domain issue. Like you literally can't plug in 3 for x because it would cause you to divide by 0. So what we say here is that we say that this guy right here is extraneous. That's all you have to say. So he's not actually a solution. He would be a solution, but when you try to plug him in, he doesn't work. So we call him an extraneous solution. Okay, that's it. I mean, that's about as hard as they get there. So we'll do one more. Honestly, if you really feel like you understand what you're doing on this, you could probably go ahead and work on the delta math right now. But I am going to do another example for you, just so you can see how it works. Okay, how about this one? Again, see how we have x minus 2 and x plus 4? I'm going to assume, hopefully, that this right here is probably the product of those two. Okay, so what we have here is 2 over x minus 2 minus 24 over, let's just double check, make sure this factors. Is this actually x plus 4 times x minus 2? Multiply to negative 8, add to positive 2. It is. Good. Okay, so this one's going to be negative x over x plus 4. So what's going to be our common denominator here? Well, we've got x plus 4. We've got x minus 2. So this guy needs to pick up the x plus 4. So let's go ahead and do that. So we're going to have 2 over x minus 2. So this guy needs the x plus 4 on the bottom and the top. Don't forget to do it on the top as well. Okay, that's a common mistake. So there's the x plus 4. The second fraction is good to go. It already has everything. So it doesn't need anything. It's got the x plus 4 and the x minus 2. Does it matter that the order is backwards on these guys here? What do I mean by that? I mean, see on this fraction, the x plus 4 is first, and on this one, the x minus 2 is first. Doesn't matter. Doesn't matter at all. Okay. Negative x. This is going to be x plus 4. What does this fraction need? This fraction already has the orange x plus 4. It needs the blue x minus 2, right? So it needs the x minus 2. So we're going to give it the x minus 2. Okay, we have common denominators here, so we're just going to get rid of the denominators. So really all we have left is the numerators. 2x plus 4 minus 24 is equal to negative x times x minus 2. Okay, let's distribute here. So 2x plus 8 minus 24 is equal to negative x squared plus 2x. I'm going to actually get everything over to the left side here. So I'm going to add x squared to both sides. And I'm going to subtract 2x from both sides. Okay, what do we have here? X squared. On the right, we have 0. On the left, we have 2x minus 2x would be 0. 8 minus 24 would be minus 16. Okay, so we have x squared minus 16 is equal to 0. This would be a difference of squares. So you can either say, look, this is x plus 4 times x minus 4, set equal to 0, or you can just solve algebraically. I usually just solve these algebraically, right? So I'm going to add 16 to both sides. So x squared is equal to 16. Excuse me. And then I take the square root of both sides. So x is equal to plus or minus 4. Plus or minus 4. Let's check and make sure this works. So if you come up to the original equation, if you plug in positive 4, it will actually work. And again, just for the sake of time, I'm just letting you know. Like if you plug in positive 4, it'll work just fine. So 4 squared plus 2 times 4 minus 8 is equal to negative 4 over 4 plus 4. That guy will work out. Okay, I think you're going to get negative 1/2 is equal to negative 1/2. I can tell you right now, just looking at it, that when you plug in negative 4, you're going to have a problem. And how do I know that? And I know it because I'm just looking at this, right? Like, look at that, x plus 4. If you plug in negative 4 right here, you're going to divide by 0. So what you're looking for on these specific problems is any number that when you plug them in on the bottom, you're going to get a 0 on the denominator, on the bottom part, okay? So if we try to plug in negative 4, you're going to get negative 4 plus 4 on the bottom there. That's going to give you 0. And you can't divide by 0. It is undefined. So we're going to say x equals 4 is our solution. We're going to say x equals negative 4 is an extraneous solution. Extraneous solution. All right. That's how you solve rational equations.